In this video, we're going to do some guided exam question practice on the 2019 question 6 on the exam paper for Junior Cert Science, and it was about chemical reactions. Okay, so it's a 15-mark question, which means you get 5 minutes to do this. So go ahead, set your timer for 5 minutes. Do that now. Okay, and we're going to begin. So start your timer. Okay, it says a student carried out an experiment to investigate the reaction between an acid and a base. So that's important. I'm highlighting those because that's the chemicals that react in an acid and a base. A pH indicator, so this is a chemical called a pH indicator, and a thermometer were used to monitor changes in pH and changes in temperature during the reaction. Okay, so the first one, it says to name a pH indicator the student could have used in its investigation. All right, so pH indicator, you have to name it. All right, so we have used 2 of these. So what I want you to do is I want you to pause the video and name one of these indicators. Okay, so this is, there's 2 options here. Hopefully you have gone for either litmus, L-I-T-M-U-S, litmus indicator, or something called universal indicator. So these are the 2 indicators we've looked at in class, universal indicator. All right, so there are the 2 options. So again, hopefully you remember the experiment doing it. It says, what color is this indicator when you place it in an acid? So first of all, remembering that an indicator is a chemical that shows you by changing color, whether it's mixed with an acid or an alkali. So when we, or an acid or a base. So when we mix it with acid, so color, what happens to the indicator that you named when you mix it with an acid? Pause the video and write down the color. Okay, well, the answer here is if you said litmus, litmus turns red. So you should have said red. Okay, and if you said universal indicator, well, it depends how strong the acid is. It's either going to be either red, yellow, or orange, one of these colors. So if you said any of these, then that is going to be correct. Well done. The next question, it says when an acid and a base react together, they neutralize each other. So that means they make a neutral solution. On the pH scale, what number represents a neutral solution? Okay, so pH. So what I want you to do is pause the video and write down the pH of a neutral solution. Okay, so you should only be playing the video if you've written down the pH of a neutral solution. If you can't, can you remember what numbers the pH scale goes from? pH scale. Pause the video and write down what numbers it goes from. Okay, so it goes from 0 to 14. Okay, so if you can't remember, if you couldn't remember that, maybe I have triggered something in your mind. The pH scale is a scale that goes from 0 to 14. It works like a number line. Okay, so can you remember where the acids were? Write down and label where the acids were. Okay, so the acids were down here on this side. Okay, so acids are down here and the alkalis are up here. So where's the midpoint here? The midpoint is pH 7. It's in the middle. So anything less than 7, we call acids, and anything greater than 7, we call alkalis. If it's exactly 7, what do we call these substances? Write it down. If it's exactly 7, we call them neutral substances. So, back to the question. Now you should be able to answer it. Pause the video, write down the answer. Okay, so what number represents a neutral solution? Well, we've just gone through the scale again. pH 7 are neutral solutions. The student noted a rise in temperature. So the temperature went up on the thermometer as the acid-base reaction took place. Is this an example of an endothermic reaction or an exothermic reaction? So pause the video and write it down, write down the answer now. Okay, so endothermic and exothermic reactions. Okay, let's think about this for a second. Here we've got a container, and in this container there is 2 chemicals reacting. Okay, now when a reaction happens, one of 2 things can happen. Okay, energy is either taken in from the surroundings and used by the reaction. Okay, or energy is, I'll get rid of those 2 arrows, sorry. Energy is given out by the reaction to the surroundings. Now, what do I mean by the surroundings? Surroundings is everything that is not the reacting chemicals. Okay, so the two liquids or whatever it is, something liquid and solid that you mix together, those are the reacting things, and then everything else is the surroundings. So if I had a thermometer in here, okay, oops. If I had a thermometer in here, like this, I'll draw it in blue. So this here, if this was a thermometer, this would count as the surroundings, as it's not one of the reacting chemicals. And for the temperature to go up here, what would have to happen is energy would have to go from the reaction mixture into the thermometer. Now, it would also be going into the room, into the glass, but some of the energy would be going into the thermometer, and that would make the temperature on the thermometer go up. So the reaction here, the mixture, is given energy out to the surroundings. So what type of reaction is this? If you didn't know it already, maybe that can help you to explain it. Pause the video, write down which one. All right, so if you still couldn't answer, then we need to understand what these words mean. Exo and endo, okay? So exit, if you think of, means to leave. We say energy, thermic then means heat. So exothermic means heat leaves the reaction. Endothermic means that heat enters the reaction. Enter. Okay, so heat enters the reaction, whereas heat leaves the reaction, exothermic. So back here, what is heat doing? Is it leaving or entering the reaction? So remember, the reaction is what's happening in the liquid. Is heat leaving it or is heat entering it? Pause the video. Hopefully now you can definitely answer this if you couldn't do it the first time. Okay, so hopefully you've realized that if heat is going from the reaction into the thermometer, then it is leaving the reaction. So it is an exothermic reaction. Exothermic is the correct answer there. The diagram shows an energy profile diagram for the reaction between an acid and a base. On the diagram, show the activation energy for this reaction. Okay, so here we have a graph that shows the reaction progressing. So as we go from left to right, the time is passing and the reaction is going more and more finished. And as we go up the y-axis, it's showing us the different amount of energy that these things have. So here we're seeing that the reactants have more energy than the products. Look, the products energy is down here. This is less energy than the reactants. Reactants have this much energy, products have that much energy. Okay, but we also see this big spike here. Okay, so we see this big spike that I'm showing in red. Maybe I'll show it in blue here just so it's more clear. You see this big jump in energy that happens during the reaction. Okay, now this amount of energy from the reactants up, this is the extra energy that had to be put into the reaction. Okay, and the reaction won't start without getting up to this level of energy. So this is what we call the activation energy. Energy. That's this here. So I should probably label it a bit tidier than that. That would be activation energy would be this. Sorry, pen stopped working here. Okay, activation energy would be here, this little hump in energy. Where do we see this? We see this when we flick a match. Okay, if we leave the matches in the box, they won't just catch fire by themselves. Okay, we have to strike the match on the side of the box. That gives a little bit of energy to get the reaction started, and then the reactants can turn into products. So this here, this little hump here, is like striking a match, providing an activation energy. So when we strike a match, that's the activation energy. Okay, so pause the video now at this stage and take down that diagram and label the activation energy. Do that now. All right, guys, so that is a guided exam question on chemical reactions, and we'll see you in the next video.